So basic routing protocol configuration is very similar to the iOS syntax. You're gonna see in a couple. The only difference is that unlike the iOS, the ASA uses subnet masks instead of wildcard masks for network statements. And ASA also uses subnet masks instead of wildcard masks also for ACL definition, as you're gonna see in a couple. So the ASA doesn't support, has not implemented wildcard masks, just regular subnet masks. Now, in order to manage remotely the ASA via, SSH, Telnet, HTTPS, whatever, because ASA is a dedicated firewall appliance as opposed to a router, which, from the router point of view, firewall is going to come up as an added feature. So because the ASA is the dedicated firewall, then it's going to run by default in what is called closed mode from the management point of view, where no remote access is being available by default. So Telnet, SSH, HTTP, HTTPS access for management is going to be not allowed by default. You have to make that happen. So to manage the ASA remotely, assuming it's going to be reachable by routing, you have to first enable the protocol with only Telnet being enabled by default. So if you want to manage it via SSH, you got to enable SSH to begin with. If you want to manage it via HTTP, you got to enable HTTP to begin with. Then you gotta configure what are the allowed IP addresses used to connect for management. Like if you want to manage the ASA from your PC, which has an IP address of 10.10.10.10.10, then you gotta tell the ASA that you allow the ASA to be managed from that IP address of 10.10.10.10. So that's what I was saying, that the ASA runs in closed mode by default. Then you also have to configure AA for authentication, which is unlike the iOS, where by default you just can configure a password and you can get authenticated with the password. Or if you use SSH, you can just configure username and password and get authenticated with username and password. On the ASA, you have to configure AA for authentication. So on the ASA, there is no AA old model and AA new model. If you want to authenticate on the ASA for management, you have to enable AA for authentication. And then, of course, you have to define users in the local database. Telnet is going to be the exception that supports likewise only passwords. But if you use SSH, HTTP, or HTTPS, you have to define users in the local database. So repeat that Telnet allows you to, as we know, connect only via a password. And also, it's let's say a less commonly known fact, but also HTTP and HTTPS allows you to connect to the ASA without the username and password, but by using the enable 15 access password. Of course, not recommended, but you can use that as an option. In general, of course, ideally speaking, you should not use Telnet, it's insecure. You should not use HTTP, it's insecure. You should use SSH and or HTTPS, which means you should use always a username and password configuration. Now, as you're going to see in a couple, when you go to the configuration side, the ASA can be configured from both the CLI and the GUI. It has a rich feature set from the GUI. The management client to manage the ASA remotely from the GUI, it is called ASDM, which stands for ASA Security Device Manager. It's not a centralized, let's say, platform. It's just a client that you install on a Windows PC, and then you can connect to the ASA to manage it. So the ASDM cannot be used to build centralized firewall policies for hundreds and hundreds of devices. You cannot just use it to manage multiple ASAs, but independently. You cannot configure centralized policies and then deploy it to all of your firewalls using the ASDM platform. For that scope, Cisco has another product which is called CSM, or Cisco Security Manager. So before we go to any further, let's just go ahead and configure the basics and also allow for management. So let's go on the ASA, as I was saying, and configure IP addresses in those two subnets, in VLAN 37 and VLAN 47. I'm going to use .16 on both sides of the network, on both interfaces, and I'm gonna name this interface of Gig01 to be my, let's say, inside interface, inside, and this one to be, let's say, the internet interface. I'm not going to name it outside, just internet for the sake of it. So let's go on the ASA. I'm connected to the console, so I don't need to enable remote management for the moment. I can just go to the console. You say show interface IP brief, not show IP interface. Show IP interface, be show interface IP brief. And you see in there that it's pretty much unconfigured, has nothing configured. Only the built-in pre-configuration. We're going to speak about certain aspects as we move on with the configuration. So let's go on interface gig 00, as I was saying. Gig 00, and I'm going to say IP address 136.1.47.16. So the order of operation doesn't matter. If you configure first the IP address, then the name if, and then the security level. As long as you can configure all of them, doesn't matter the order of operation. And then you say name if internet, name if internet. There we go. It's going to have a security level of 0 by default, as I was saying. Only for the inside name if you get a security level of 100. Otherwise, for our name if is going to be a default security level of 0. And no shut. Exit. Then interface gigabit 01. IP address 136.1.37.16. Name if inside. And there we go, at a level of 100 by default. And no shutdown. Exit. Now let's go on the switch side and configure the ports in the proper VLAN. So the switch port facing gig 01 has to be in VLAN 37. And switch port facing gig 00 has to be in VLAN 47 on AS8V. So looking at the physical diagram, AS8V gig 00, AS8V gig 00, AS8V gig 00 is connected to switch 2's port 1016. That has to be in VLAN 47. So switch to port 16 in VLAN 47. Switch port mode access. Switch port access VLAN 47. Span port fast just to put the port in instantly into forwarding mode, and no shutdown. Show span interface FA1016. It instantly went to forwarding. There we go. And show span interface FA1016 detail. I also see that port fast is enabled. And then gig 01 has to be in VLAN 37. And if you look at the physical diagram on AS8V, gig 01 points to switch 1 port 17. That has to be in VLAN 37. So switch port mode access, switch port access VLAN 37. Likewise, penalty port fast just to make the port instantly forwarding, no shutdown. And let's say show span interface, show span interface FA1017. And should be to forwarding in VLAN 37, and there we go. Which means if I go on my ASA now, and I say show interface IP brief, then I should see both of those links up in the app state. There we go. Let's verify the nameifs. Show nameif. And there we go. Gig 00 has a nameif of internet and a security level of 0, while gig 01 has a nameif of inside with security level of 100. If you say show IP address, it's going to show you the IP addresses. Gig00 has an IP address of 4716/24, and Gig01 an IP address of 3716/24, name of inside. Now looking at a physical, the logical diagram, I want to have basic connectivity with 3 and 4. So let's see if the ASA can ping router 3, the connected layer 3 neighbors, and router 4 on the connected subnets. So let's go on the ASA and say ping 136.1.37.3, and there we go, it works. And ping 136.1.47.4, and let's look on router 4. Show IP interface brief, extrude unassigned. Router 4 is up and running, but it's connected to switch 3. So probably switch 3 is not initialized. Let's say connecting tab file. Let's go to switch 3 and quickly configure that switch up as well. Show VTP status. Let's say VTP, let me quickly reconfigure switch 3, VTP mode transparent, and VTP mode client. VTP, let's configure VTP so it's going to get the VLANs from the other 2 switches. Show VTP status and show VTP password to see the VTP domain and VTP password, if any. So this is my password and my domain is going to be this. So on switch 3, I say VTP domain this, VTP password the same. Do show VTP status. Okay, and now let's configure the trunk between switch 2 and switch 1 and switch 3, for example, which is going to be on switch 1 is going to be port 1021, and on switch 3 port gig 1020. Let's make those 2 ports and trunks. Let's go on switch 1, show run interface FA1021. Switch port trunk encap.1q, switch port mode trunk, no shut. And on switch 3 is going to be port gig 1020. This one seems to be up and running. Okay, show VLAN brief. Let me see if the VLANs have been updated, and yes, they were. So now let's see router 4. Let's look back at the logical diagram. I gotta make sure that router 4's FA00 is in VLAN 47 on the switch side. And if you look at the physical diagram, router 4 FA00 is connected to switch 3 on port gig 101. I gotta put that port into VLAN 47. Let's go on switch 3. Undebug all. Show run interface gigabit 101. There we go. This has to be in VLAN 47. Switch port mode access. Switch port access VLAN 47. Span to port fast and no shut. Let's make sure there's no routing enabled, and you remove this. There we go. Now I have just quickly enabled connectivity also on router 4, because router 4 was not properly attached to VLAN 47. I should go now on ASA3 and be able to ping router 4 on the connected subnet. Let's go on ASA3 again and test that connectivity. So I'm just testing now control plane connectivity between the SA and the connected devices on those two segments. And there we go.